Okay, so planetary gears. Okay. So we're talking about planetary gears. You've got three main parts to it. You're going to have the sun gear, which is the center. You're going to have the ring gear, which is the outer, and then you're going to have the carrier, where the planet pinions are held. When we're talking about the ratios in a planetary, the ratios are pretty simple. Sun is just whatever the tooth count is. Ring is just whatever the tooth count is. The carrier, we don't count the teeth on the pinion gears. What we do is we add the sun and the ring tooth count together to give us our total equivalent tooth count for the carrier. Okay. Standard gear ratio logic applies anytime you're talking about planetaries. If you've got a little gear driving a big gear, that's going to give us an underdrive. It's going to give us a decrease in speed, but an increase in torque. So if the sun gear is driving the ring gear, there's a way to make that happen. We have to hold the carrier stationary. But if I hold the carrier stationary, what that also means is all of those planet pinions are going to act like reverse idlers. And if the sun gear is turning clockwise and the idlers are going to turn counterclockwise because of what's happening with the sun gear, that means those are also going to cause the ring to turn counterclockwise, which tells us one thing we need to know about planetary gears. If you hold the ring, or sorry, if you hold the carrier, you effectively end up reversing the rotation of the output. All right. When we're talking about planetary gears, we can hold any of the components stationary and then use one of the other ones as the input and the remaining one as the output. And depending on which ones we're holding and which one's input and output, we can get a variety of different gear ratios out of it. If I was to hold any two components together, that effectively locks the whole thing up and it puts it in a direct drive scenario. So there's just a quick refresher on planetary gears for you.